Hey everyone, and welcome back. It is fantastic to have you with us again as we continue mastering IBM DB2. In our last session, we looked at the big picture, the architecture of the database, and the incredible power of the mainframe. But today, we are going to zoom in. We are going to get practical. We are moving from the what and the why to the how. Today's topic is the fundamental building block of any relational database, the table. We are going to explore how to create them, how to choose the right data types for your columns, and we're going to tackle a concept that trips up almost every beginner, the concept of null. By the end of this video, you will be able to write a create table statement from scratch and confidently choose between an integer and a decimal or a character and a variable character. Let's get started. First, let's set the stage. If a database is a library and a table space is a bookshelf, then a table is a specific book. But unlike a regular book where you just write paragraphs, a database table is highly structured. It is a grid of rows and columns. Every column must have a name and, crucially, a specific data type. You can't just throw a date into a column designed for numbers. This strictness is what keeps your data clean and queryable. Before we write any code, we must talk about data types. Choosing the right data type is the most important design decision you will make. It affects performance, storage size, and data integrity. In DB2, we generally categorize these into three main groups: numeric, string, and datetime. Let's start with the numeric types. These are for storing numbers, but not all numbers are the same. First, you have your integers, whole numbers without decimals. DB2 gives you three main options here based on size. You have SMALLINT, which uses only 2 bytes of storage. This is great for small counts, like the number of children in a family. Then you have integer, or just int. This is your standard 4-byte number, handling values up to about 2 billion. Finally, for the big data, you have BIGINT. This uses 8 bytes and can store massive numbers. If you are generating a unique ID for every transaction in a bank, use BIGINT. But what if you need decimals? What if you're storing currency? This is where many students make a mistake. They choose float or real. Do not do this for money. Floating point numbers are approximations. They can have tiny rounding errors. For money, you must use the decimal data type. In DB2, you define it as decimal, parentheses, p, s, where p is precision, the total number of digits, and s is scale, the number of digits after the decimal point. For example, a salary column might be decimal 9,2 to allow for salaries up to $9 million. Next, let's move to strings. This is text. The two heavy hitters here are character and variable character. Understanding the difference is critical for performance. Character, often written as CHAR, stands for fixed length. If you define a column as character 10 and you store the name Tom in it, DB2 will store Tom, followed by 7 spaces. It always consumes 10 bytes. This is perfect for data that is always the same length, like a 2-letter country code or a fixed product SKU. Variable character, written as VARCHAR, stands for variable length. If you define a column as variable character 100 and store Tom, DB2 only uses space for Tom plus a tiny bit of overhead to record the length. It saves space. So why not use variable character for everything? Well, the fixed character type is slightly faster for the database to read because the rows are predictable. So the rule of thumb is if the data length varies, like a name or address, use variable character. If it's fixed, use character. For truly massive text, like storing a whole chapter or an XML document, DB2 offers CLOB, character large object. These are for when you exceed the limits of a standard variable character. The third category is date and time. In DB2, we have 3 distinct types. Date stores just the day, month, and year. Time stores just the hours, minutes, and seconds, and timestamp stores both, often down to the microsecond. If you're auditing when a record was changed, always use timestamp to get that precise point in time. Now that we know our ingredients, our data types, let's cook. Let's look at the create table syntax. The basic command is straightforward. Create table, followed by the schema and table name. Then inside parentheses, you list your columns. Let's imagine we're building a table to store employee data. We might call it employees. The first column is usually an identifier. Let's call it EMP_ID. We'll make this an integer. Now here's a pro tip. You often want the database to generate this number for you automatically so you don't have to worry about duplicates. In DB2, you can add the keywords generated always as identity. This tells DB2, you handle the numbering, start at 1 and go up by 1. Next, we need the employee's name. First, _name. Since names vary in length, we use variable character. Let's give it a limit of 50 characters. Then, perhaps the higher _date. Naturally, we use the date data type. And finally, salary. As we discussed, we use decimal. Let's go with decimal 9,2 to allow for salaries up to $9 million. But we're not done yet. We need to talk about constraints. A constraint is a rule you place on a column. The most common one is the primary key. The primary key uniquely identifies every row. In our example, EMP_ID is the best candidate. By adding primary key to that column definition, DB2 will ensure that no two employees ever have the same ID. It also builds an index automatically to make searching fast. Now we need to discuss a concept that is often misunderstood: null. What is null? Beginners often think null means 0 or blank space. It does not. Null means unknown. It means the value is missing or not applicable. Imagine you have a column for middle_name. If I don't have a middle name, what should be in that column? It shouldn't be a space, because a space is a character. It shouldn't be 0. It should be null. However, nulls can cause headaches. If you try to add a number to a null, the result is null. 5 plus unknown equals unknown. Because of this, we often want to prevent nulls in critical columns. This is where the not null constraint comes in. In our employee table, last _name should definitely be not null because everyone has a last name. The higher _date should be not null, but middle _name, that should allow nulls. When you design a table, you must ask yourself for every single column, is it possible for this information to be missing? If the answer is no, add not null. Let's refine our table design with one more advanced feature: default values. Sometimes, if a user doesn't provide a value, you want a safe fallback. For example, let's add a column called status. We want new employees to be active by default. We can write status, variable character 20, default, active. Now, if the insert statement skips this column, DB2 automatically fills it in. So, putting it all together, our statement looks like this: create table, employees, open parentheses, EMP_ID, integer, not null, generated always as identity, first _name, variable character, 50, not null, middle _name, variable character, 50, last _name, variable character, 50, not null, higher _date, date, not null, salary, decimal, 9,2, default 0, primary key, open parentheses, EMP_ID, close parentheses, semicolon. Once you run this command, DB2 creates the structure in the table space. But remember, physical design matters too. If your rows are very wide, meaning they have many columns with lots of text, you need to make sure your table space has a large enough page size. If a single row is larger than the page size, say 4 kilobytes, you'll get an error. Always calculate your row length before creating the table. Let's briefly touch on altering tables. In the real world, requirements change. You might need to add a column later. The command is alter table, followed by add column. However, be careful. If you add a not null column to a table that already has data, DB2 will complain because the existing rows won't have a value for the new column. You have to handle that carefully, often by providing a default value. Before we wrap up, let's summarize the key takeaways from today's session. First, we learned that a table is a structured grid of typed data. Second, we explored the critical data types: integer and BIGINT for counts, decimal for money, and float for scientific data. We learned the difference between the fixed-width character and the flexible variable character. Third, we mastered the create table syntax, including how to use identity columns to auto-generate keys. And finally, we demystified null. We learned that it stands for unknown and that using not null constraints is vital for data integrity. Understanding these basics is the foundation of everything else you'll do in DB2. If you get the table design right, your queries will be faster and your data will be cleaner. In our next video, we are going to start putting data into these tables using the insert command, and then we will learn how to change it with update and delete. You are building a complete toolkit, step by step. If you found this explanation helpful, please give the video a thumbs up and subscribe to Topictrick. We are committed to making these technical concepts easy to understand for everyone. If you have questions about which data type to use for a specific scenario, drop a comment below. We love to hear from you. Thank you for watching, and happy database designing.